Hey everyone, it's Darren. Welcome. Today's video, we're going to talk about the distinction between accuracy and precision. These terms, a lot of people use them interchangeably, but they actually mean two completely different things. They're both measurable, and there are times when you care about one, there are times when you care about the other, there are times when you care about both of them. And we're going to talk about what that is. So if we look at, this shot, hey, I've got great accuracy, great precision, right? I hit the bullseye. Perfect. Okay, well, what if we have high accuracy and low precision? Well, what does that mean? Well, if we think about this, high accuracy, the easiest way to measure accuracy is to measure the average value. And yeah, I'm sort of all clustered around where I want to be. It kind of averages where I want to be. And sometimes that's fine. For example, let's say that I'm a farmer and I know I need 5,000 gallons of water per acre per day in order for my crops to be happy. Uh, Now, if I happen to put 6,000 gallons on it today and 4,000 gallons on it tomorrow, it's not going to make any difference. As long as I sort of hit that average, over several days, over a week, I'm just fine. What I don't want to do is hit 10,000 gallons today, then zero, then zero, then zero, then zero, then 50,000 gallons. So you get too far out. So I don't care that much about accuracy, but I do need to have sort of some precision. So I need to cluster it sort of. So like this example here on that bullseye, that would be just fine for that. Um, what about high precision and low accuracy? And there are cases where that's fine too. Uh, so here's high precision, low accuracy. Kind of missed the bullseye a little bit, but they all went exactly the same spot. And there are cases where that's fine. And if you're wondering where, there's an example that we can look to from space research. On the moon, there's a few mirrors that were left up there by various missions to the moon, whether manned or unmanned. And from the Earth, they shine lasers up at that and get the reflection back. And they measure that, and they can tell a lot about the movement of the moon relative to the Earth. Okay, so what happens if you shine the laser up and it's 10 miles to the left? Every single time you shoot it, it hits the same place 10 miles off to the side. Well, that's an example of high precision, low accuracy, but it's also an example of one that's really easy to fix. Just move your aim back over. And now every time you hit, you're going to hit that mirror perfectly. It's not where you're technically aiming, but it doesn't matter. You don't care. You're hitting it perfectly, and that's high precision, low accuracy, and it suits your needs just fine. So, what about high precision, high accuracy? Well, this is what most of us would love to see. Every time would love to see high precision, high accuracy. Um, can't always hit it. You can sort of try to get there. In this case, let's say that you are making parts to that need to fit together. They have to fit together perfectly. Uh, that's where you need high precision, high accuracy. Uh, some auto parts are made to, like body parts might be made to a 1 millimeter precision. Uh, if they're more than a millimeter off, then we can't use them. They won't fit. Engine parts are made to tiny fractions of a millimeter. If you work in a machine shop, you're in thousandths of a millimeter, tens of thousandths of a millimeter, fairly routinely. So that's accuracy and precision. Now, what can we do to actually measure accuracy and precision? Well, let's take a look. So on the bullseye, we had two dimensions. Here, we're going to make it a little bit easier. We're going to only have one dimension here today. Uh, we're going to be measuring 1 meter long rods. I need rods of metal that are exactly 1 meter long. So that's what I'm ordering from my supplier, and my supplier is going to be returning metal rods to me for me to use in whatever I'm building. So easiest way to measure accuracy is just to take an average. So here I have, I think, 100. No, I have 1,000. So I have 1,000 data points here. Those are the lengths in millimeters. So equals average A1 to A 1,000. Hey, great. I have my average is 1 millimeter over. Uh, okay, that's not bad. Except if you look at the data, you see all of the rods were cut at either uh, half a meter or 1.5 meter. Uh, I can't use any of those. They're all scrap metal. Uh, so that brings in what we look at for precision. And precision, you want to use standard deviation. So if we look at standard deviation, typically you want to use dot P, dot A. I'm just going to use dot P here because it's not going to matter. Uh, and I want A1 to A 1,000. That tells me that my standard deviation, which check out the standard deviation video if you don't understand standard deviation. The short version of what it is, it tells you how far away the average thing is from your average. So my average item is 499.999 millimeters away from the average. Uh, so it's a half meter off. And we can do a little bit more with these. Before we go on to those, I do want to say if you're getting anything, if you learn anything from this video, be sure to hit like. Also subscribe and hit notify so that you can see when I have new stuff come out. That really helps with the YouTube algorithm. It gets the information on the video out there to more people. More people can see it. The channel can grow. Channel grows. We stay motivated to keep making these videos for everyone. Also, I do have a Patreon page at patreon.com/data analysis excellence. If you're able to help out there, that'd be great. As I'm recording this, I'm working on getting it set up so we can offer early video releases to Patreon supporters. So let's take a look back here at some more information though. So here I have some data that's a little bit closer. Um, these, if we look at the data where this came from, uh, column A is between 990 and 1,010 millimeters. Column B is between 950 and 1,050 millimeters. So you see there's quite a bit of difference there in the accuracy and precision. So let's take a look at accuracy and precision. If you notice the numbers changing every time I move, that happens because the random functions in Excel are not static. Every time you reference them, the numbers change. Makes for more random data, makes things look a little funny sometimes, but that's fine. So if we look at the accuracy of column A here, that is average of A1 to A 1,000, especially if I put the actual A in there. So very accurate. Precision of A1 to A 1,000 is off by about 6 millimeters. Um, so I set it up to be between 990 and 1,010 millimeters, and on average, it's off by 6. Okay, so let's take a look at the other one here too. Um, oh, this is column A, that one's column B. A1 to A 1,000. B1 to B 1,000 would probably work better there. So B1's not too far off either. That's off by 400 by 0.4 millimeters. So then I do precision is standard deviation of B1, B1000. Standard deviation's off by quite a bit more there. And you see these accuracy and precision numbers, they change every time the random numbers change. Uh, so you may be wondering what can you actually do with this accuracy and precision data? If you're manufacturing, these are the numbers that you mostly care about. The other number you're going to care about, though, is an acceptance rate. And acceptance rates is kind of critical. If I'm buying my parts from somebody else and I am telling them I want these 1 meter long metal rods, and they're sending me metal rods like in this one over here. I can't use a single one of those. Those are all scrap metal. So let's take a look at some acceptance data here. Acceptance is almost the same. It's kind of, well, it's different, but it uses standard deviation. Basically, acceptance is saying these are the parameters I'll accept. If I'm outside of those parameters, I'm not accepting the part. So what we're going to use here is a function count ifs. And if you're familiar, there's links to the description, down the description for count ifs as well. If you know count if, which is used a lot more often, count ifs just lets you put in multiple criteria. So I'm going to do count ifs A1, A1000, and criteria is going to be, um, let's say I want my criteria need to be between 999 and 998. Excuse me a second. I held my key down too long and tried to turn on hotkeys. So criteria is going to be greater than 998 and A1 to A1000 is going to be less than 1002. And before I hit enter here, if you notice, I have quotes around the values there. So it's quote greater than 998 quote. And you do need to have the quotes. You can actually build strings if you're using a cell reference. You could do quote greater than quote ampersand and then a cell reference. Uh, that's all covered over in the COUNTIFs video. But let's look at this, and I have only 223 that actually meet my requirements. So I did less than 998, or sorry, I did greater than 998 and less than 1002, which means it has to be 999, 1000, or 1001. So if I change these, so if I broadened up my specifications a little bit, that is a 5. Um, now I have 694 out of 1,000. And since it's 1,000, you can actually also just do a divided by count A1, A1000, which will give you a percentage. So I have 70% acceptance rate here. Um, so acceptance rate is really useful to know, both for internal and for suppliers. Like I said, if my supplier is sending me stuff and I'm rejecting 95% of what they sent me, I need a new supplier. Um, Same time, if you're measuring your internal performance and you see that this one machine is having a high failure rate. So I have 10 machines and 9 of them are giving me 95% acceptance rate, and this last one over here is consistently giving me a 40% acceptance rate, or even 80% acceptance rate. I need to fix this machine. Uh, could be it's the person, could be it's the machine, but it's something worth tracking because that will save you a lot of time and money. Uh, so that's really about all I have for accuracy, precision, and acceptance. Very useful things. They're not interchangeable. But they are very strongly related. Again, if you learned anything from the video, be sure to hit like. Also, subscribe and hit notify. That really helps out the channel a lot. We're trying to grow the channel, trying to get this information out to more people, and that's how we do it, is by liking and subscribing to the videos. Also, if you could help me out on Patreon, that'd be great. Links down in the description. And I look forward to seeing you next time. Have a great day.